It's 2 minutes past, so I'm going to start. Does anyone object if I make a photograph so that I can send it to my children going, look, where I was, is that okay? Someone mind? Everyone's happy? Say cheese. Great, thank you. Very briefly, an intro on my background. As I mentioned, I'm based in the Netherlands, and I travel to Karlsruhe often because my biggest client there is the FIZ Karlsruhe, which is one of the Leibniz Institutes for Information Infrastructure. I studied computer science a long time ago in the 1990s. And then in the 2000s, I sort of switched to more cultural things and did book history and manuscript studies because I was working a lot in the cultural domain. And that sort of introduced me to the whole idea of knowledge engineering because I was working so much with metadata and data in general. And so having one foot in each camp turned out to be very handy of both the technical stuff of the computer science side and then books, because I love books. And so studying book history gave me this very interesting perspective on how knowledge has been managed over the centuries. So it's amazing when you take a book and you hold it in your hands and this book is 500 years old and you can still turn the pages and read the information. It's just mind-blowing stuff. And then eventually I ended up at the FIZ Karlsruhe working on this project called the NFDI for Culture Consortium. Just some brief background on what that's all about. The NFDI is my German is now going to be bad, Nationale Forschungsdateninfrastruktur, funded by the DFG. And for all different parts of science, they set up these consortia, mathematics, bioimaging, material science, chemistry, blah, 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 blah. But one of the very first ones was NFDI for Culture. And it's a consortium for research data for material and immaterial cultural heritage. And what makes our consortium so interesting is it's very widely ranging. So architecture, art history, musicology, theater studies, dance, media studies. So it's very, very different and fuzzy cultural data. Which makes it quite challenging and which I actually really enjoy. It's not just the hard sciences. So it's a very, very stimulating field to be working in. These were the founding members of the NFDI for Culture. I mean, as you can see, it's a very broad collection of different, both universities, archives, and even some museums within the consortium. Now, hands up before I go to the next slide. Has any of you ever heard of RDF? Does it ring any bells? So, great, which is really good. Because then then it's actually useful that I can speak about it, because I was unsure if I should skip all the next slides or not, and just continue going. The RDF data model was invented by Sir Tim Berners-Lee, the same guy who made the World Wide Web. And this was in the beginning, just when the web was this like new great thing and everyone was very excited about it. They said, can we actually make web pages and information more structured? How can we make it not only these web pages with HTML and sort of these like kind of messy, fuzzy things, but give it a structure? And if you have a web page, can you make it machine readable, which is the important point? And they came up with this thing called RDF, and it was shepherded by the W3C, and it was, for many people, a really great thing. But in a way, it failed miserably because the uptake was really, really bad. And people had to invest a lot of effort and time into this thing. And it's an incredibly abstract way of looking at stuff. But now, 20 or 25 years later, we're having this resurgence of RDF, because actually back then it was just way too visionary and people couldn't understand what this Tim Berners-Lee guy was going on about. So we're having this sort of resurgence of RDF, and we're using it within our consortium. And also the group that I'm part of at the FEZ Karlsruhe of Professor Harald Sack. Is also the link for the description of this session. I posted a link to his YouTube course on RDF, which I highly recommend you look at. And then you're asking, why is he talking about RDF? What's the big deal? Before I continue, do you know that problem when you make an Excel sheet and you've got a list of things, I don't know, music albums, people, whatever, and then you have this thing where one of the fields has multiple stuff in it? Do you recognize what I mean? And you have to send someone this thing. You've got rows and rows, but there's like 3 keywords or 4 album names in the Excel. And so you go, well, do I make another sheet and like have 2 sheets? And then do I have like make a link between these 2? It's a very, very common thing. And how do you solve this? Now, what people often do is they say, you need a relational database. So you don't have to read the details. It's just to show you these tables. Now, has any of you ever had a database course somewhere and this idea called normalization? And it's what you do when you have your data. So in the spreadsheet thing, you've got a row in my Excel, album names, and then with multiple keywords, and then you split this into multiple tables. You can't really, we can't see this big screen, so you can't really see that on the big screen here. But essentially, you're splitting this spreadsheet or this list of stuff that you have into just the relevant things. So you have, and in this case, this is using a data set called the Chinook database, which is often used in data science circles as an example. And it's a music store. So you've got an invoice, and in the invoice, someone bought an album, but an album is made by an artist, and an album has many tracks. And so you have these little links between things. And so if you do a course in databases, you will learn how to normalize your tables. And this is what you do. You create these separate tables. And when you do RDF, you do that same thing, but you keep on going. You normalize everything until you've got only one table left. And it's like mind-blowing. How does this work? And this one table has got 3 columns. An ID for something called the subject, the field name or the predicate, and the object. And so then you can link just these 3 things, and you take all these different tables and you boil this down into these 3 columns. Someone is a poltergeist breathing at us. Right. And so this is RDF, and it works incredibly well. But the first time you encounter this, you're like, oh, what? How do I do this? How do I go from all these tables into this one remaining table with the 3 columns? And I'll show you an example. Can you actually see that on the screen? Is there no way that we can make this big screen? It's a little bit better. Yeah. Can we try and dim the light? Just the front one? Maybe we can see better. Is that better for you? I don't mind the lights off. Yeah. Yeah. So here I'm trying to show this example of what we did with these album names. We've created 3 columns, and in each case, so ignore the word Chinook. It just happens to be that data set's called Chinook. Yeah? Album 1 has a label and the album name. The album has an artist, and the artist has an ID. The artist has a label, the artist label, and then a track is linked to an album. It's a very abstract thing, I know. Bear with me. There's a reason why I'm explaining this. We'll get there. So you break all your information, all your data up into these 3 columns always, and you just keep on going to extreme. Everything has an ID. everything has a field and then some value. And that third thing, the third column, is either a text string. So like you can see, there's an album name, Jagged Little Pill, or Alanis Morissette, or it's a link to another thing. So you create this spider web of things in these three columns. And why do we do this? There's this thing called Metcalfe's law. He was a telecoms engineer, and he said basically as a summary, the value of things that you create, it's higher the more links you create between things. And they did that in the telegraph network. When if only two people have a telephone, there's not much value in it. But as soon as you add more links between these different people, and he expressed it, he actually did some calculations determining this, and it's n squared. So if you've got 4 people, it becomes 16, etc., etc. It just gets much more useful. So creating these links between things gives things value, called the network effect. And we can do that same thing with data. So instead of this thing that we created with these 3 columns, we add URIs to these IDs on the web. So if you're making your data, give it a link for both the IDs of your things as well as these properties. And then you're linking to each other's data, and it becomes a lot more useful. And this network effect becomes visible. And I know, once again, bear with me, this is a bit abstract. Where are you going with this? Why are you doing this? I'll show you in a moment. So 2 things, you make everything these 3 columns in RDF, and you give things URIs so that you can link them to other people and other websites. And this is then called the concept of linked open data. So you might have seen this acronym before, LOD, here and there. I'm not sure if any of you have noticed this one yet. And especially in the academic world, it's becoming more and more interesting, and it's finally taken off. And this idea of linked open data was pushed by Tim Berners-Lee when he did this 25 years ago, but people didn't understand what he was talking about. And now it's taking off. So places like the tax service or museums or the train service all publish their data as linked open data using these concepts of RDF triples and URIs. And now you can link your different systems together and make them talk to each other, because it's using a standardized way of talking to each other. And it's taken like 20 years for this to take off, but finally we're getting there. And every time here and there you see people publishing their data and they go, there's also LOD, there's also linked data, and you go, it's very exciting. And it used to be very difficult to convince people to do this, but it has taken off. I'm sticking in this slide because I won't go on about it too much, but it's useful to follow this link later on if you do happen to look back at the slides. The importance of making linked open usable data. You can make lots of linked open data, but it doesn't become useful, and then things fall apart. And Robert Sanderson is one of the big proponents of creating linked open data, and he's created a lot of standards in this field. Has any of you known or used Wikidata? Ring any bell? 2 people are nodding. So this is another example of a huge value of creating RDF and structured data. Wikidata is actually a German project from Wikimedia Deutschland. And it started off by taking all the data that's in Wikipedia and turning it into this structured RDF data with triples. So whenever you're looking at some Wikipedia page, there's a corresponding Wikidata page of the Wikipedia, but in the structured format. So I'm going to click as an example. Let's hope this works. You can still see my screen. Yes. Here's the page for Berlin in Wikidata. So you can see there's all these statements with these 3 things. So the subject, the whole time that we were talking about, is Berlin. And in my address bar, you can't really see my address bar. It's a URI, wikidata.org/wikiq64. And this number, Q64, is the number for Berlin. So that's the subject in this 3-column thing. And now you see here on my screen, there's the middle part. I need to enlarge this a bit. Is it now readable? Yeah. So instance of is one of these field names in the predicate. So I'm going to scroll down. Part of, inception, image. So this is this middle thing every time. And then in the third position every time, you'll see there's multiple of these things. And this is a nice view of looking at it. It's a nice human visible thing. But we also have what it looks like under the hood, which normally you don't want to see. But it comes back to these. I'm going to scroll down. The problem with Wikidata is they support many languages. So you see just lots and lots and lots of languages you normally don't want to see. I'm scrolling down. Woo! There we go. And so here we've got these triples for Berlin. And yes, I know this is not human readable, but it's just to give you background into what I'm trying to convey is this RDF thing and this triple story, which I'm going on about, is not pie in the sky stuff for people saying one day if we do this, it would be nice. It's now become real. And if you go to Wikidata, you can go and do structured queries for the most amazing things and get actual data. So it's if you do nothing else from this, if you take away nothing else from this talk except Wikidata to look at, then I'll be happy as a win. It's an incredible resource to go and see. No, the initial one was, but now it's a human curated thing. And so humans go and edit stuff.
The wiki page, someone is transforming it to a Wikidata page.
Yeah, and Wikidata has now also become its own thing. So people edit it separate from Wikipedia. It's become so useful. People just actually create Wikidata pages only for the data. And you can add your own stuff. So you register, I don't know if you're a Wikipedia user, register, and then you can edit Wikidata. You can go, I'm looking at the Berlin page and that entry saying something is wrong. You can fix it. And, that's the whole power of the whole wiki idea. And it has the most diverse projects. The one which I'm particularly keen about is one called The Sum of All Paintings. And it's a Wikidata project for cultural heritage, listing all the paintings in the world that people know of in galleries everywhere. And it's fantastic. So people go and type up, they take a photograph, they put it on Wikidata, and they say it's in this gallery, it's in this museum, it was painted by this person, and they just curate this knowledge collectively. And it's really quite amazing. And if you personally want to, I don't know, you're doing your knowledge management thing in Obsidian, I went on holiday and I visited this and this and this place, and I want to link to an actual official page for that, you can use Wikidata. You could say, I went to this place, I visited that, I saw this. It's a way of sharing data, and Wikidata becomes this hub for doing that. Now, big swing, returning back to NFDI for culture. We're doing the same thing in our consortium for all these different data sources that we're getting. But we have a lot of data. There's more than 70 actual data portals that are all sharing their data, saying we've got data, and over 100 million items in these portals that we know of. And it's very diverse. It's in all kinds of sources. There's XML in there and JSON and raw bitmap files and IIIF things. Just it's nuts. And we are trying to now harvest all this data, extract it in a pipeline, then transform it into this RDF format, which we just talked about, and then publish it in a standardized way so that people, when they go looking for data, can find it and consume it and use it in a standardized way. And why are we doing this? Because we want to connect all these different research data bits so that you can ask strange questions. Like, for example, are there dragons in the NFTI for cultural research data? And then you want to be able to ask this from either an image archive or a music archive or maybe theater performances. And how do you link all these different things? And how do you actually link things if the word dragon, for example, was never used in a theater performance, or in the music it was in German, but the performance was in some other language. So these are the kind of challenges we have. And this is the kind of spaghetti you get if you've got these three columns of things. You just have these links to everything and everywhere, combining them. And it becomes, which I really enjoy, how do you solve this and how do you make these things talk to each other? And the other problem is these different archives all have different levels of information which they're sharing as well. You know, sometimes it's just a website and they don't use any of these RDF stuff. It's just they're publishing their stuff on a website. Sometimes they've got proper structured data. And sometimes they even have really good RDF sources with a Sparkle endpoint. Now, if you've ever used a database course, you must have heard of SQL, the structured query language. Now, for RDF, there's an equivalent called Sparkle. And that's how you query this kind of RDF data and linked data. So if you go to the Wikidata page and you want to go and search for all restaurants within 10 kilometers of Berlin that serve Vietnamese food, in Wikidata, you can do a query like that. You can say, you know, give me this information, or give me all painters that are blah, 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 or persons that were born in Bratislava who died in the last year who are famous whatevers. So this kind of queries you can do on Wikidata. And we want to do the same thing for our research data. So what we've built is a knowledge graph-based research data management approach. And we've called it the culture knowledge graph. And we're building this index across all these different data sources and data portals. And we've separated it into data about the consortium itself, who are the people, who's the institution, you know, who's affiliated with what, and the actual data. This is the data portal, this is the data formats, this is what they provide, and here's the actual data sections. A reminder, please interrupt me. So if I'm like, you know, going on, the whole idea is for it to be a bar camp session. So, you know, if you have on a tangent, we've got lots of time, we can digress, and I'm keeping an eye on the time that we've got lots of space to discuss. And I'm doing it on my own laptop, so I can like switch to actual tools and we can dig in deeper if someone wants questions. So
maybe one, how do you put the Sparkle?
can we throw the mic? Can we throw the mic for it? We don't have any online people, do we?
Sure.
Okay.
Hi. Yeah. How do you fill the Sparkle input into the search, or how do you do a search or a query to Wikidata? Maybe
you have immediately hit the nail on the head. People have a love-hate relationship with Sparkle, and the people who love it say, you just have to invest some time and learn Sparkle. Normal people say, forget about it. It's too hard. We're not going to do it. Never in a month of Sundays. And the tricky thing is, if you have to ask me in which camp am I, I'm in both, depending on what day of the week it is. I used to hate Sparkle, to be honest. I mean, I have a degree in computer science. I've written software but these Sparkle queries are just so damn hard, and sometimes you cannot make them work. And then on a different day, you manage to get one working. You go, holy crap, this is amazing. I've just done this query on Wikidata and it works, and then it's amazing. But to be actually really honest, I don't think Sparkle it's reasonable to expect normal users to use it and create Sparkle queries. It's just really, really difficult. But the magic bullet here are these LLMs. So what has now happened is you can ask an LLM, please make me a Sparkle query that does blah, 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 blah. And until, I don't know, maybe a year ago, so it was not so good and it was really crappy. But the LLMs, as you all know, the pace of acceleration, the speed, not the speed, but the speed of the acceleration is just going up like this. And stuff that we used to think was impossible, and in 6 months' time, it just happens. So Sparkle queries now, you can ask your favorite, whichever LLM you use, please write me a Wikidata query. We can actually try that in a moment as well and see if it works. And I'll probably be embarrassed because it's not going to work like that. But yeah, so you ask an LLM to do it.
Yeah.
Okay, and where do you trigger this query then? Is there a portal in Wikimedia
Yes.
or
Let me immediately
input
jump
field?
there. We
Don't
have
know.
the time to do so. Where was my Wikidata link? Yeah. So if you go to the Wikidata page, let's see, which one shall we pick? I'm trying to think what the best, shall I pick an existing thing? No, let's just go to the query page. So on the left-hand side, you'll see there's one of the links is query service, and then you get this query page where you can do some queries. And the nice thing is there's an examples button, and you can go and look for the examples there. Once again, can you read my page? Sorry, it's not very... what shall we... Can anyone read any of those? And does anything jump out that you think, yes, let's do that? Someone shout something, help me choose. Here's one, it seems nice and obscure. Map of the world's sign languages with number of practitioners. Which is like, okay. Let's hope it works if we now run the query. Yeah. It gives us a map of the world's sign languages with the number of practitioners of it. So Dutch Sign Language has 15,000, etc. And this query, as you can see, has these triple things. And if let me just delete all of this so that you can see it properly. But here's this triple idea coming back. Question mark sign languages, that's the variable. So I want all the sign languages. And the property here is P31. It's the type of thing. So give me the thing that has the type. And here we have this thing, sign language. So that's sort of like a simple query. And if I ignore all the map fancy things, I'm just going to say, give me the sign language. And I'm going to run the same thing. I'm just removing all the map parts. You can see this is just the raw query. Just give me these Q numbers. If I click on one of them, it's some sign language somewhere in the world. in Ivory Coast. Okay. So you can see here this Q number as an instance of the type of this thing. It's a sign language, and it has a country, Ivory Coast. And each one of these things in the third column that it links to again is once again another thing with a Q number. So that big Q number there has a country, Ivory Coast. And if I click on that thing, it jumps Ivory Coast also has a number, Q, blah, 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 blah. And that has all these different fields and properties. So you can see how it's like the spider's web of things, and you can follow your nose to various things. And because they're all URIs and it's on the web, you can link things together. So if we scroll down, I'll get to that a bit later in the presentation, actually, using authority files. Trying to see if we can get an example here. Boop, boop, boop. Now, I'll get back to that in a bit. Notice that you have geo coordinates in here, images. It's also very rich. You're not limited to text. And you can do the same kind of thing for your own data, using very rich links to different places. Does that answer the question about the query thing? Yeah? Yeah.
Thanks.
And the thing is, if you type these yourself, they get very tricky, but it then helps you ask the LLM, please give me a thing to blah, blah, blah. I'll leave it until the end of the presentation, and then we might circle back and try a live LLM query and see if it works. And so I can delay my embarrassment if it doesn't work. Right. So we've done the same thing for NFDI for culture. And what do we use? And I have a bit of a cop-out in my answer here. And this is that, Python. I am a completely Python prejudiced aficionado, and I mean, I absolutely love it. And I've been using Python for 25 years. And if there's another thing that you take away from this talk, if you can manage to afford to spend some time and invest some time, learn some Python. It saves you so much time in so many places. It's unbelievable. And with the coding agents that you have nowadays inside your LLMs, they can help you create Python scripts, even if you're not a super duper programmer. It's become shockingly good. And you can say, I want to do this and this and this. Please make me a small script that does this and this and this. And it can give you Python scripts. And I can't go on enough about how much time it saves me to be able to do something small using Python. So you've got a bunch of Excel files on your disk and you want to read them, extract stuff from it and convert it into a different thing. You can do it with Python. If you've got your Obsidian Vault and you want to read through all of your notes and you want to try and extract the markdown and do something with it, Python is your friend. And the Python motto is batteries included. So there is a Python module for almost anything you can imagine. Reading Excel files, creating, you name it, it can solve most of your problems. So I absolutely love it. And I use it every day for almost everything we do. And in this whole NFDI for culture stack that we've created, Python is a very, very integral part of that whole thing. And more specifically, within the Python universe, we use several tools, which I'm listing here for completeness. And you can look at it back later on the presentation, but you don't have to immediately go into the details here. One of them, which I've become incredibly enamored by, is this thing called Fast HTML. Do any of you ever create websites? No one's a developer here, one person. So when you create websites, it's super irritating that you've got all these different moving parts and you've got to learn JavaScript and you've got to learn build systems and backends and how do you deploy it and where do you run it? It's just this spaghetti nightmare. And this project called FastHTML has solved a lot of that stuff. It's in Python, but you create all your front end stuff and all your web parts in Python. And it just makes, it's like this breath of fresh air where you just kind of relax and you go, I can just, do all my stuff in Python and not worry about it so much. So probably not, I wasn't sure who would be in the audience. So maybe I'm preaching to the wrong audience, but if you ever want to do web application stuff, these are some of the tools that we use. And these other ones they're called triple stores. So these are like the database engines in which you store this RDF data. So I'm mentioning them here just for completeness, but I don't expect you to use these. These are for professionals who want to publish at scale this RDF data. Then these are the tools we use. But in your case, you would use other tools, which I'll get to in a moment. So in the process of doing all of this, here are some tools that I've created in the past 3 years at NFDI for Culture to help us manage our data and do our stuff. And the first one is called Schmarkle, which I love the name. It came to me because I was like Sparkle, Schmarkle. When I created it, I was in a phase where I was hating Sparkle. So I was like, meh, Schmarkle. And it's a tool which, if you've created some of these RDF data and you want to publish it and browse it, you can easily then just, read these files and use them. And it's on that URI. At the moment, it's aimed at a technical audience. So you've got to know a little bit what you're doing. So you've got to install Docker and you've got to run it from your... Do people use Docker? Does it ring any bells or anyone? Once again, apologies, it's a technical thing. It's another tool, you can install it on your laptop called Docker, and it saves a lot of hassles for you if you want to run software that someone made somewhere, because it standardizes how you actually run these different pieces of software. And it's like having your own little Linux server on your laptop. So if someone somewhere had made some tool that they want to share, and they want to run it or share it with you, and you've got Docker, you can run the same software that the Wikidata that you saw, you can run Wikidata on your laptop using this thing called Docker. But you need to be fairly technical. But if you take that hurdle, it's really a game changer in life. That was Schmarkle, yeah. And the other one was Wikidata, and that's even more technical. So sorry, it's maybe not so relevant for the audience once again. But it was an easier way to query these large collections of RDF files. I don't think it's relevant. I'm not going to talk about that too much. So what we did for NFDI for Culture is we brought all of this different things together, and we created the NFDI for Culture Data Search, which is a website which I can actually briefly go to. We have enough time. I, at random now, just typed in keyword Bach. And what it's now doing is going over all these different research data portals to try and find things related to that keyword. And we've got music and images, etc., from all these various things. And people don't have to type Sparkle queries. So it's all RDF and Sparkle and everything under the hood, but we're hiding this from the end users so that they don't have to type in these kind of queries. And I'm not sure these drop-downs are, yes, they are visible. As you can see, we have all these different data types, different data standards, authorities that we're trying to bring together on this website to make it a little bit more user-friendly. And the next one that's very, very important is this idea of authority data. So as we were linking these things in that third place where you put in a URI, which one do you choose? What URI do you use? And that's where authority data comes in. So when you choose something, you use a link that people have agreed to what the link could be. So it sounds very abstract, I know. For example, the GND is the Gemeinsame Normdatei of the German National Library. And they record URIs for everything that's published, for example. So for every book that's published in Germany, it gets one of these URIs. For every author in Germany has one of, not only Germany, it's broader than only Germany, gets one of these URIs, and they publish it and they maintain this giant list of URIs. So if you want to say something about something, you use one of these official URIs published by an official place, and then people, when they're talking about the same thing, can actually share and make sure that they're talking about the same thing, completely language independent. And as you can see, there's many different of these authority systems for the different kind of thing, but you can use them to bind together your different domains that you're working in. And the blue corner there at the top, you'll see something called Iconclass. That's another one for art history and cultural heritage in general, which is very close to my heart because I made it. And I've been maintaining Iconclass also for the last 25 years or so. And that's the same thing for every concept. Gets its own unique URI. So if you're talking about something like a painting of the Virgin Mary with Christ on her lap, with his head turned to the left, there's a specific URI for that scene. Or if you're talking about hatred, there's a URI for the concept of hatred. Or for love, or unrequited love has its own code. And so in that third position where we're describing something, if we're talking about something, we can add in these codes to link these things together. And because it's URIs with a number in it, it's not linked to language. So it doesn't matter if I'm talking about love or someone else is talking about liefde. It's all language independent, and we can make our things talk together and talk to each other. We have time. I love showing this because, yeah, it's close to my heart. Here's what I was talking about, this idea of these codes. So you can see it's very abstract, but each one of these concepts in this hierarchy, in this tree, has a unique number. And because we've done this also in the NFT Afro Culture system, and we're using Iconclass, we can link different websites together. So for example, we're looking at fist fight. It's a good one. So I want to see, is there something about a fist fight in the Bildindex in Marburg in Germany? So if I click on this link, we can go and see, yeah. So there's some nice images about fist fights in the Bildindex. And that's the power of using these authority files and the linked data with these three columns to link your things together. And at the Bildindex, they've also been using Iconclass for the last 30 years and using this structured way of doing things. So these things can talk together. And across different countries, so this is the Dutch Art History Institute in Florence, and I'm looking at fist fights in Florence, and there's one, I only have one, not enough. They've got a picture for exactly that thing, the fist fight. Yeah. But you can also see here are cross references. So someone made an image about a fist fight, but you also have a lover's tussle. So these are now very similar, but slightly different. And I think you can get the idea by using URIs for stuff, you can become either extremely exact, I want this thing, or you can dial your knob and saying, no, I want to zoom out slightly more. I don't want to have an exact fist fight. I want to just have people fighting in general, or lovers fighting, or these kind of ideas. And if we do this on collectively, we can share our data and actually link our things together by using these shared standards. Yes, I think we're almost done. Shall we take the?
You have another.
Sure.
How do you prove the uniqueness of such a key? So how does someone know, okay, fistfight is already existing?
They go and look it up.
Okay,
the
so
website.
they need, before creating it, having a look in the database,
Yes.
checking, okay, all right, thank you.
Have you got more examples what let's call it deliverables look like? So you combine the different data, and what does it look like? Here it was a portal where I could look up pictures, but maybe it's also a different kind of visualization, or I get a table of data or a list of something when combining the data.
So maybe the question is 6 months too early, because what we're working at now, we've built this base within this data search, but it doesn't have nice visualizations yet. It's just a thumbnail and a table, and that's super boring. So what we want to do, and this is, we've now gone into the second phase, is to add visualizations. You want to have a network diagram, you want to have a map, you want to have a flow chart showing how people have changed from this one to that one, a time series. So this is what I'm working on right now, is adding these visualizations onto this website. But we're just not there yet. We have to hurry up and get that done. But because we invested a huge amount of effort into the foundation, you're welcome to come inside if you want. Yeah, thank you. Because we invested so much time in the foundations, we can do these visualizations and make them happen.
Maybe the next step. So that's.
Yeah. But if you look at the Wikidata, you'll see there's lots of visualizations and stuff in there already. So, yeah.
And maybe regarding the sources, you've mentioned that there are quite a lot of websites you're using as source. Are there any else, like documents or like other systems behind?
Yes. You know Zenodo? Does that ring a bell? I didn't put a link to there. There is a website that is maintained by the CERN in Switzerland called Zenodo, where you can publish documents. And we publish all our presentations, all our slideshows, all our technical reports on Zenodo.
Okay.
And that contains all the details and the background stuff on what we've made, how it's made, some background information. There's lots of slideshows there. And if you look at the NFDI for Culture website as well, this one, nfdiforculture.de, there's lots of guidelines, publications, all the links in there that you can have a look at.
Okay.
But a good reminder, I should put the Zenodo link on there. I think we're almost done. I'm feeling the pressure from all the other sessions finishing. We're done. Thank you very much for your attention. I'm glad there were people.